Alright, hello Science 10. We're looking at balancing equations again. Alright, this time I've got an example that includes polyatomic ions, okay? So, I've got NH4PO4 plus barium hydroxide, okay? And then we are turning into Ba3PO42 NH4OH, okay? So, this is a skeleton equation, right? We have the equation, but we don't know exactly what the coefficients are going to be in front of these here. Okay, so when it comes to balancing equations that include polyatomic ions, we are going to consider any polyatomic ion to be a single unit. Okay, so we're going to look at NH4 as if it was one unit, similar to just like a barium ion. Okay, so NH4 is considered one unit. So when we are setting up our table for balancing, we're going to write, NH4, PO4, Ba, and OH. Okay, so we don't combine the hydrogens and the oxygens and anything like that. We leave it exactly like this. It makes it much easier to balance than if we just tried to combine and count how many hydrogens we had and stuff like that. Okay, and then on the other side again, we'll write, and I like to keep, even though barium is now in the front, I still like to keep them in order. So the NH4s are, the top thing on my list here. PO4, Ba, and OH. So let's have a look here. How many do I have here? I've got 3, 1, 1, and 2. And on this side, I have 1, I've got 2, I've got 3, and I've got 1. Okay, so start from the top, start with the most obvious thing. All right, how do we turn this 3 into this 1, or this 1 into that 3? We can multiply this side by 3. Okay, so if we multiply this side by 3, that means we're putting a 3 up here right now. Let me make a little bit more room. So we've just put a 3 in front of that molecule, which means that this turns into a 3. So I'm going to cross it out. And then what happens over here to the OH, right? Because this 3 applies to both. This turns into 3. And we do another look. We say, okay, are we balanced? We go, okay, well, not quite. So now let's look at this one. We'll double that guy, right? So the PO4 we can double to get to 2. Now if we put a 2 up here, we're good here. We end up with a 2 here. But again, this applies back to the NH3, which means this NH3 turns into a 6. Okay, and again, we're just going to rinse and repeat. Now we go back up to the top and we say, okay, are we balanced? Not quite. We need to multiply that by 2. Turning this, I'm just going to erase it really quick here. Turning this into a 6. So again, we've just turned this number into a 6. So what happens to its respective number down here, the OH? The OH becomes 6. All right, so again, back up to the top. 6s, so the NH4 is balanced. 2s, the PO4s are balanced. Okay, let's look at the BAs. They are not balanced. So we can multiply this side by 3. So we're going to put a 3 up here. What happens when we multiply by 3 there? We're also going to turn this into a 3, and this goes 3 times 2 is 6. All right, so let's have a look. 6 and 6, 2 and 2, 3 and 3, 6 and 6. This is finally balanced. Okay, so we have 2 of the first molecule, 3 of the second, 1 of the product of the first molecule, and 6 of the second one, okay? Remember, if it's just a 1, you don't need to write it. You can just leave it as is. The 1 is implied. So this is a completely balanced equation using polyatomic ions. All right, that's it for this example. Take care.